Sir, shall I start? Okay. Today I am going to explain top theory concepts. For this, I am using MATLAB Online 2000 V version. So this is the online version, so we'll get limited number of options. So limited number of options we'll get. So first I will explain how to draw the graph using MATLAB. Then I will go to how to find out shortest distance between two vertices, shortest path, and spanning concepts. For example, not this, sorry, online class. So, for example, suppose I want to draw this graph. This is a directed graph. Am I correct? This is a directed graph. I want to draw this graph. For that, what we have to do? We have to write ordered pairs, vertices like this. We have to collect the edges. So there is an edge from 1 to 2. Am I correct? There is an edge from 1 to 2. This is a directed edge. There is an edge from 1 to 2. First of all, we have to write all edges. There is an edge from 1 to 2. Next, 1, 2, 3. Two to 4. There is 7 to 1, not 1 to 7. This is. Next is 2 to 4. Next 3 to 5. Next 3 to 5. 3 to 5. Only 3 to 5. Am I correct? Next 3 to 4 also there. Am I correct? 3 to 4 also there. 3 to 4. 3 to 5. 3 to 4. 3 to 5. Next 4. 4 to 5. 4 to 5. 4 to 6. 4 to 5. 4 to 6. Next 5. 5 to 8 only. Next 6 to 1. 6 to 1. 6 to 8. 6 to 1. 6 to 8. Next 7 to 7 to 1. 7 to 2. 7 to 1, 7 to 2, 8 to next last one, 8 to 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13 edges. 13 edges are here. So after that, what we have to do? This is our main diagram. We can forget this. This is our these are the edges. Now you take MATLAB version. MATLAB. This one. This is online 2020 version. So first you have to write starting edges, starting vectors. 1, 1, 2, 3, 3, 4, 4, 5, 6, 6, 7, 7, 8. 1, 1, 2, 3, 3, 4, 4, 5, 6, 6, 7, 7, 8. Next, T. Any name, A, B, you can take A. 2, 3, 4, 4, 5, 5, 6, 8, 1, 8, 1, 2, 3. 1, 1, 2, 3, 3, 3, 4, 4, 5, 6, 5, 6, 6, 7, 7, 8. 2, 3, 4, 4, 5, 5, 6, 8, 1, 8, 1, 2, 3. Now we entered edges. Now, so G is equal to our digraph. It is a diagram, directed graph. No, it is already came digraph of edges S comma D. It is like this. Digraph is generated with edges, 13 edges, nodes, 8 nodes. Okay, if you want to see that plot G. It takes time. This is the directed graph. Okay, so this is the directed graph. This is the directed graph. Okay. So this is a 2000 version. We'll get everything labeling by label title will come here. So direct, if you want to title, this is the latest version, you know. So if we click that one, label X label will come automatically. X label like this. Okay, like this. Actually, we not needed. So I am removing this figure window, closing. Okay. So this is the way of plotting a graph in MATLAB. Actually, I don't prefer this MATLAB to draw the diagrams. Why? Because so there are other softwares to get a beautiful diagrams. So if you want to get any information from the MATLAB, so we have to create a diagram. So this is a common procedure. First we have to give starting edges and edges, diagram. So plot is not necessary. From this diagram we can get the information. For example, P is equal to path from one vertex to another vertex. There is a direct diagram is there here. This is the diagram. I want to find out I want to find out the distance between 7 to 8. Vertex 7 to vertex 8. Path or the shortest path. So there is so many ways are there we can move from 7 to 8. 7 to 1, 1 to 3, 3 to 5, 5 to 8. That is one way. 7 to 2, 2 to 4, 3 to 4, 3 to 5, 5 to 7, 3 to 7, 7. There another path. 3 to 7, 7 to 1, 1 to 2, 3 to 2 to 4, 2 to 5, 4 to 5, 5 to 8. So many paths are there. What is the shortest path? That we can find the command P is equal to. There is a two ways are the path and distance. B. Shortest path and distance. Shortest path. Shortest path of our graph is G. This is our diagram G. Already G came. G from vertex 7 to 8. For example, vertex 7 to 8. Vertex 7 to 8. So the shortest path is 7 to 1, 3 to 5, 5 to 8. The shortest distance is 4 inches. 4. Okay. Shortest path. Now, how to create the shortest path is very useful when these edges are present. No. Weights are present. So, for example, weights means it may become traveling cost. What is the cost of constructing network? Whatever. I'm taking another example with weights. With weights. Weighted graph. Example 2. Example 10. So this is weighted graph. Am I correct? This is a weighted graph. Directed weighted graph. Weights are there. It may be traveling cost or networking cost, whatever it may be. If you are the 3 to 1. This is 4 is weight. It may be transportation cost. It may be network cost, whatever it may be. If you want to move from vertex 3 to vertex 1, you have to pay the weight from 3 to 4. 3 to 1 is 4 units. 4 like this. So how to draw this diagram? First thing, how to draw this type of directed graph. For that, again the procedure is same. Here we have to do carefully. So 1 to 2 weight is 2. 1 to 2. This is weights. 1 to 2. Next 1 to 4. 1 to 4. 1 to 4. 1. Only 2. 2 to 2 to 3. Weight 4. Weight 3. 2 to 5. 10. 2 to 5, 10. 3 to 1. 4. 3 to 6. 5. 4 to 3. 2. 4 to 5. 2. Weight 4 to 6. 8. 4 to 7. 4. 5 to 7. 6. 7 to 6. 1. This graph is now. Two, 4, 3. I am missing. Oh, yes. 2, 4. I am missing. Okay. Thank you. 2, 4. Anything? 2, 4, 3. Okay. 2, 4. Oh, sorry. Not 2, 3. 2, 4. This one. Okay. 2, 4. Thank you. The rest of the thing okay, na? Rest of the things. So remaining things okay, na, sir? Michael? Okay. Okay. Thank you. Now, any name you can give it. I'm taking it. Previously, I've taken ST. 1, 1, 2, 2, 3, 3, 4, 4, 4, 4, 5, 7. 5, 7. B is equal to 2, 4, 4, 5, 1, 6, 3, 5, 6, 7, 7, 6, 7, 7, 6. Wait, it's W I'm mentioning. C also we can do. There is not a big issue. 2, 1, 3, 10, 4, 5, 2, 2, 8, 4, 6, 1. Wait. We have to enter starting points, end points, and weights. The same procedure. G is equal to, what is it? One digraph. Am I correct? Digraph. Digraph of A comma B comma W. A comma B comma W. Previously we have given A comma B, S comma T. Here we have to give starting points, starting point array, end point array, weights array. So because we are going to plot weighted graph, we are going to create weighted graph. So 12 edges are there, weights also there, nodes 7. 7 nodes, edges, 12 edges. Okay. If you want to see the plot of what is the graph here? G. Am I correct? G comma. And the one more thing here, edge label is important. Edge label. Automatically will come. We have to give enter. Edge label, comma, double. This is the advantage of new version. Okay. Plot G, edge label. This is not necessary for me. I am closing, minimizing, and maximizing this one. Okay. Plot G. We'll get a graph. Invalid expression. Here wrong is, what is wrong? Double graph. Okay. It is online version. It takes time. Okay. This is the graph. Okay. This is the weighted graph. Weighted graph. This is my weighted graph. Okay. Some options are not working here. There is a problem. Why? Because it is online version. Online version. Okay. Now, if you want to find out the shortest path from one vertex to another vertex, from 3 to 7, for example, vertex 3 to vertex 7. Why? Because why did I choose? Because the reason is we cannot go like this. We cannot go like this. Am I correct? We cannot go like this. So there is a 3 to 7. I want to move 3 to 7. I want to find out the path from node 3. It's in degree, out degree, everything you know. I don't want to explain the in degree and out degree. In degree means how many edges are incident to that vertex. Out degree means how many vertices are going from that vertex. Like this. From node 3 to, I want to find out the shortest distance path from 3 to 7. Okay, 3 to 7. So for that I am closing this one. Okay, CLC. So plot is there with me already. Is not plot, graph G is there with me. Am I correct? Now path distance. Otherwise B comma D, not a problem. D is equal to ED is equal to shortest path of G from 3 to 7. 3 to 7. Capital G or small g. Whether I have given small g or capital G. I will check it. In the previous graph maybe. Small g only. Okay. 3 to 1, 3 to 1, 4 to 7. This is the shortest path. I have a graph, What is there is a graph? This is my graph. Both are same. 3 to 1. This MATLAB is telling 3 to 1, 1 to 4, 4 to 7 is the shortest path. 3 to 1, 1 to 4, 4 to 7 is the shortest path. The weight is 1 plus 4, 4 plus 1 plus 4, 9. 4 plus 1 plus 4, 9. That is the shortest weight, total transportation cost. Okay. If this network is very simple, actually this network is very simple network. If the network is very complicated, then so MATLAB will help you a lot. Okay. Okay. Nagaraj, ఒక 10 minutes తర్వాత ఫోన్ చేస్తాను నీకు. బిజీలో ఉన్నా. ఓకేనమ్మా. So now I concentrated on directed graphs. Now the next thing is how to create non-directed graphs. That is undirected graph. Suppose if you want to create undirected graph, the same thing, same graph I want to make it as undirected graph. I want to create. Otherwise, you take any undirected graph, we can do. That's not a big issue. So I am taking the same graph. Okay. I want to make it as an undirected. How to create undirected graph? Already G is there with me. Am I correct? Already we have. So again, I am drawing. I am creating graph G. Try to tell graph. But the H I will take. Already G is there with me. I am taking H. If you want to create a non-directed graph, try to undirected graph, non-directed graph, both are same. Undirected graph or non-directed graph. That simply we call it as a graph. Am I correct? Only if it is a directed graph, we call it as a digraph. Otherwise, we call it as a graph. Am I correct? Okay. Next, a graph. What are the vertices previously? S, comma T, A, comma B, A, comma B. Previously, I mentioned yes. Next, A, comma B. Same graph. A, comma B, comma weights W. I'm closing. As a graph is created. Suppose I want to plot undirected graph. G, comma, edge label, comma W. Directed graph came. Leva. CLC. What is the previous one? I'm sorry. A. Next, W. This is one advantage. Directly you can select W. Undirected graph G is equal to some H. Oh, I wrote plot G. So this H we have to write, I created H. Sorry, H. I created H, H is equal to graph of A comma. So that is a mistake. A comma B comma W. So actually I created H, but plot I given a G. That is a problem. So H is there. H is created. Plot H, not G. Plot H, comma H label W H. We will get undirected graph. We have undirected graph. Okay. Okay. So this is the way of creating. If you want to get any information from this graph, shortest path. I am talking about shortest path. So because the other things are very difficult. So different people are there. So common things you can easily understand shortest path and all this. Shortest path, spanning tree also you can easily understand. That's why I have chosen two topics in the graph. Okay. I will explain brief. I will give brief explanation, a brief introduction, a brief discussion about spanning tree. Then I will solve.
Sir,
Yes, sir.
sir, is it possible to change the color, vertex
Yes,
color?
everything you can do. Do you think you can? I told you, general graph is there. Suppose if you want to plot anything, so
Yes, sir.
edge color, you want to change the color,
Yes, sir.
that you can. This color you want to change, edge, this color.
Yes, sir.
So edge color, you have to take edge label W. Plot G is there. Okay, G. Edge color. This is what one thing. We are in. This is the thing. This is the problem with online version. So I
Okay.
didn't download uh, MATLAB 2000. Directly, I'm using online
Yes, sir.
version. That is a problem. For that, how to change color map, color thing. It is not done. 1 second, I will change. Okay. Color edit. Where is the edit button? Edit button. Plot edit. Start of time. Okay. Color grids, everything. Color node color. If you want to change the node color, you see this one here. If you want to change the node colors, so if you want to make it as another color, we can do like this. Color was changed. Am I correct or not?
Yes, sir.
Did you understand?
Yes, sir.
You want to change the marker, circle. You want to give a circle, we can give circle.
Okay.
Okay, circle. Okay, did you understand?
Yes, sir.
Only if you want to change this edge color. Okay, edge color. All this general I explained in this one. It's color change. Am I correct?
Okay, sir.
Okay, na?
Okay, sir. Fine, sir.
If that like that, we can.
Okay, sir.
So actually, I am facing some problem here, right? Because this is online version, so it takes time, and also sometimes we cannot get proper output also. Okay.
Okay, sir.
Now, if it is a licensed version, we'll get the info. We will get a nice output. Who asked this question? What is your name,
Michael.
sir?
Michael, sir.
Yes, sir.
Michael.
Like, okay, okay. I too not that much familiar with the 2020. Up to 16, I'm very familiar. So 20 also I have to check immediately. I cannot tell immediately. That's why I'm checking all the time. So that the basic thing is okay na. So the 2007, 2008 or 2009 or 2000 basic back foundation is same. So different output. The what we call it is makeups are different. Or next, what is that spanning tree? No? This is spanning tree. Okay, this is the thing. Straight away, I'm going to what is a spanning tree. Okay. So tree, we know what is this minimum spanning tree. So we know the definition of a tree. A tree is a graph with the following properties. A tree is a graph with a tree is a connected acyclic graph. Okay. So we cannot find any cycles. This is not a tree. This is not a tree. It is not connected. This is not connected. It is a connected graph. Connected graph means we can move from one vertex to another vertex. That is a connected graph. Okay. This is a connected graph and a connected graph with no cycles is called a tree. This is called a tree. What is a minimum spanning tree? That is very important. Minimum spanning tree means let G is equal to B comma E be undirected connected graph. A subgraph P is called a spanning tree. Spanning tree. A subgraph. A subgraph of G is called a spanning tree. If the subgraph is tree and it covers all the vertices of V, these 2 points are enough. It should be a cyclic connected graph and covers all the vertices of V. For example, I am taking this graph. This is one of the spanning trees. Am I correct on it? It is covering all the vertices of the given graph and no cycle. This is also another spanning tree. This is also another spanning tree. Okay. So I draw three spanning trees. Of course, it may possible more than three. Three only. One, this 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 one. So that's it. These three are the spanning trees. Okay. So what is a minimum spanning tree? This is a spanning tree. Spanning tree means the subgraph should be a tree and it covers all the vertices of it. It covers all the vertices of V. That is called span. What is a minimum spanning tree? That is very important. Minimum span, if G is a weighted graph, suppose G is a weighted graph. Suppose G is a weighted graph. A minimum cost spanning tree of a spanning tree, which has a minimum total cost. The minimum spanning tree or a minimum weighted spanning tree. One second, one minute. No, 5 minutes. A minimum spanning tree, a minimum weighted spanning tree covers all the vertices of a given graph and it is acyclic and it gives a minimum total cost. Okay, minimum total cost. Minimum total cost. Total cost means minimum total weight. Total weight is minimum. That is a minimum spanning tree. So for example, suppose like this graph is there. I want to I want to move from one vertex to another vertex. I want to cover all the vertices, and the minimum total weight should be minimum. Like that, we have to convert. I have to create one network. I have to cover all the vertices. I have to include all the vertices in my graph, and as well as total weight should be minimum. That is minimum. That is called minimum spanning tree. So anywhere we use most of the, suppose this is the layout is there. This layout is there. This is from this wiring cost from this place to this place is some value is there. Wiring cost from this place to this place is some value is there. Wiring cost from this place to this place is something is there. Wiring cost from this place to this place is something is there. Like that, one network is there. I want to create one network which covers all the vertices, all the houses with a minimum wiring cost. This is the minimum wiring cost. Okay. So this length, these weights are lengths are there. Something I created. It is not exactly like this. So like this, how to create minimum spanning. For example, this spanning tree is like this. One connected undirected graph is there. I want to create one network. I want to create one minimum spanning tree, spanning tree with minimum cost. Minimum cost and minimum transportation cost. So there are so many algorithms are available in graph theory, minimum spanning tree. Okay. So MATLAB is providing beautiful solvers, beautiful inbuilt commands to find out minimum spanning tree. For that, what we have to do? First, we have to enter a graph. There is a command min span tree. So whereas with a simple command, we'll get a minimum spanning tree. Okay. Minimum spanning tree. This I don't want to touch all these things. The advantages of minimum spanning trees, these are the minimum. These are the application of minimum spanning tree. Consider application of where n stations are to be linked using a communication network. The laying of communication links between any two stations involves a cost. The problem to obtain a network of communication links, which while preserving a connectivity between stations, does it with minimum cost. And the ideal solution to the problem would be to extract a subgraph term minimum cost spanning tree. That is minimum spanning tree. Am I correct? So many applications salesman transportation problem. Am I correct? Salesman transportation problem. That is also comes under minimum spanning tree only. Minimum cost spanning tree. Okay. So many things in pipelines, making electric wire connection on a control panel, designing local access network, constructing highways or railroad spanning several cities. Like that, so many applications are there. Now I am taking one problem. I will take one graph. I will explain how to construct a minimum spanning tree using MATLAB. So for that, I will take one minimum spanning tree example. So I've taken very simple thing because entering this get nodes and everything we have to do. That is very complicated. So simple thing. First I am writing all the things. This is a big thing. I have to enter all the things. 1, 2. Here we should be very careful. 1, 2. It is undirected graph. 1, 2 I entered. We should not enter 2, 1. 1, 2, 50. 1, 2, 50. So 1, 2, 1, 3. 1, 3, 60. 2. We should not enter 2, 1. Already I entered 1, 2. No? 1, 2 I entered 50. 2, 2, 4. 2, 4, 65.
2, 5, 40.
Ma?
2, 5, 40. 2 to 5, 40.
1, 2, 4 I meant. 2, 5. Next 2, 5. 2, 4. 5
40. 5 to 6, 70.
No, 3. You start from 3.
Okay. 3
3
to
is otherwise
7.
you
3 to 7, 45.
no, 3 to 4. Systematically better. Otherwise, you'll get
To
confusion. 3 to 4, 45.
52, sir. 3 to 4, 52. 3 to 7, 45.
Four to one or 4 to 2, 4 to 3, 4
4
to
to
4
5,
to 4.
50. 4 to 6, 30. 4 to 7, 42. 5 to 6, 70.
4 to 7, 42.
5 to 6, 70.
That's it.
Mm.
That's it. Now, what we have to do? We have to go to online. Now, A is equal to two, 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 5, 2, 7, 5, 6, 7, 8, 60. This well. 45, 50, 42, 70. Now, I am taking P is equal to plot H. Previously, I have given H. Now, I have given graph. First, we have to create graph now. G is equal to graph A, comma, B, comma, double. And edges are there. 7 nodes are there. Weights also there. So, P is equal to plot. The graph is G, comma, edge label, double. This is my graph. I'm removing this one. These are the everything. I have created a graph. Now P, my graph is, what is the graph? My graph here. The name is important. P. So T is equal to. The command is min span tree. Min span of G. Min span tree of G. So minimum spanning tree is created. Okay. Suppose if you want to see the edges. T dot edges, I think. I will check whether it is correct or not. Yes, T dot edges. So T dot edges, that's correct. T dot edges. So the spanning tree 1 to 2, weight is 50, 2 to 5, weight is 40, 3 to 7, weight is 45, 4 to 5. From the given graph, this is the spanning tree. 4, 5, 50, 4, 6, 30, 4, 7, 50. Suppose if you want to see the graph, highlight. Yes, highlight. Highlight is a command. My graph is P, comma T. First object I have removed. No? That's first you have to create. P plot. This is from this. I have to highlight this one. No? Highlight P, comma T. It's my spanning tree. I highlighted this. Highlight means I am highlighting my spanning tree T. T is my min span tree. No? From the given graph P, P is my graph. From that P, I am highlighting this T. T is my spanning tree. Okay. T is my spanning tree. This is the way of finding minimum spanning tree. This is my minimum. It is covering all the vertices. Am I correct? It is covering all the vertices, and it is a connected acyclic graph. Is called min span tree. Minimum spanning tree. Connected acyclic graph is a subgraph of G with the properties covering all the vertices and as well as acyclic. It's called spanning tree. Min span tree is a minimum cost spanning tree. Okay, this is about graph theory concepts. I covered two important concepts. With these basics, you can develop, you can calculate required values. So with this, I am closing MATLAB. Tomorrow I will start LaTeX. For that, I sent some WhatsApp messages. So you see, I will show the procedure. I will show the procedure. MATLAB first. I am opening my WhatsApp messages. First step is you have to install MATLAB from Tech Studio. MATLAB is MATLAB.org. That is well known. MATLAB.org. MATLAB.org. It is coming like this. Yes. MATLAB. It is a free software. You can download from this one. First, you download this MATLAB and run the program. Okay. So we'll get MATLAB console like this. MATLAB console like this. MATLAB console. MATLAB console. We have to get after installing, we'll get an icon like this. MATLAB console. Okay. After that one, we go to Text Studio. This is the back end. This is a standard LaTeX file. LaTeX. From this also we can work, but the Text Studio is there. Text Studio. Like this is a xstudio.org. This is a advanced version of MATLAB. So straight away we can download this one. After downloading this one, we'll get a like this. If you type Text Studio, we get like this. If you open this one, you'll get a window like this. Suppose if I'm taking new window, you'll get window like this. You have to get like this window. Okay, so I'm maximizing this one like this. Okay. So after installing MATLAB and Text Studio, you will get an icon like this in your desktop or in your MATLAB folder. You will get a folder like this. Text Studio from Text Studio. So this like this symbol, like this symbol. This Text Studio symbol. So minimum requirement for this to download all these things, you should have 64-bit. 34, I don't know exactly. That 64-bit laptop or system. Okay. So one more thing, you will face a problem also. Sometimes you will face a problem while installing. So your network, your Wi-Fi speed you should have. If you have Wi-Fi, it will be installed correctly. If you install through mobile, it creates a problem, no doubt. Okay. So if you install through mobile network, you install at the time of 12 o'clock or 1 o'clock or early morning 3 o'clock, early morning 4 o'clock. At the time, mobile speed will be high. No? Otherwise, if you install at 6 o'clock for 7 o'clock, means it will not be installed properly. It creates problem. Okay. So why? Because it is a free version. It's not a license. It is a free. So if your mobile, if your network is internet is Wi-Fi means it will be installed properly. If your network internet is Wi-Fi, mobile network, mobile data, it creates a problem. Okay. This is about installing processor. Otherwise, you go to simple thing is you go to YouTube, how to install MATLAB. Okay, so installation process. This is this other. Okay, you can see this one. This is better. Some standard, some people are there. I will tell you. David Ross. So first you type this one. Is okay. He's also a nice person. He's expert in LaTeX. Okay. You go through this video, and based on his instructions, you follow. You follow. Install this LaTeX. After this LaTeX, how to install Text Studio? It's very simple. Text Studio is very easy. Text Studio. Text Studio is very easy. Okay, it is very simple. If you install MATLAB, automatically it is very easy. You go through this person. Some people are the experts in LaTeX. Yusuf is also very expert. Okay, you can see this is video also. So many videos are there. Use of videos, you know. Very simple. Yes, it will not create any problem. But the only thing is network issue. You will face a network issues. If you want anything, you want to ask. Anything you want to ask? Sir, sir, I'm leaving, sir.